Experiment 8, dehydration of alcohol. So with dehydration of the alcohol, we are going to get two products. It's either 1-methylcyclohexene or 3-methylcyclohexene. So when carbocation forms first, is going to form where we had the OH group, and then if the hydrogen is removed from the clockwise from the carbon that carries the CH3, we get the product of 1-methylcyclohexene. If it's attached from the left side, which is counterclockwise, is going to give us the double bond on the opposite side, and we are going to get a 3-methylcyclohexene. So we could have the hydrogen abstracted from the right side or from the left side of the carbocation, and as a result we get two products. So what is the purpose of today's experiment? Is to identify which one of the two is going to be our product. I wish I was able to prove that, but we are not going to be able to prove it 100%, because is the GC, one of the methods that we can prove this, it's to find the concentration or percent composition of 1-methyl versus the 3-methylcyclohexene. Since we don't have the GC working today, we do have two brand new GC, gas chromatography. They are not plugged into the right power, so they don't work. We do need like 220, and we only have the 110 in that room or in the lab. Unfortunately, it's not working, so we are not able to identify which one is going to be the major product, which one is going to be the minor product. But what we could do, we can identify that we actually get the product formation of the final product. So we will prepare alkene. How do we prove that we have alkene? Can anyone answer that question? How can we prove that we do have alkene as the product? You could do Bayer's test. Okay, when you do Bayer's test meaning that for unsaturation, you can add Br2, like what you learn now in lecture, that with the Br2 you're adding, the color is going to change, or you could add permanganate. The color of the permanganate is going to change from a purple color to dark brown color precipitate. That means it has reacted with the CC double bond. Because if you don't have the carbon-carbon double, none of the two is going to work. That we are talking about the bromine or the permanganate. And if we have the carbon-carbon double bond, both of them would give a positive test result. So we can prove that we do have the product. Unfortunately, we cannot prove that the 3-methyl is going to be minor and the 1-methyl is going to be major. If we did prove that, we actually had proved the Saycev rule. So Saycev rule meaning that more substitute alkene is the more stable alkene, and that is going to be major product, and that will show higher percentage or the peak area for the product. Do you have any questions about the purpose of the experiment? What is your reactant? What's your reagent? Is the product. In this case, since we already know about the chapter 8 reactions, I wanted you to look at the chemical reactions and look at all the concepts that you learn in lecture. What you learn in lecture when you have a chemical reaction. When you have a chemical reaction, you want to make sure that you know what is your reactant, what is your reagent, What is your product? If you have more than one product, which one is the major product, which one is the minor product? That's like when you are learning about the chemical reaction in lecture as well as in the lab. But in the lab, we have a different aspect. We have an added concept or aspect to a chemical reaction. What we want to know, what is the limiting reactant here? What is excess compound? If you have only one reactant, that is the limiting reactant. If you have more than one reactant, then you find out what is the reactant, what is the excess compound. You want to know if your product has formed or not. So in order to identify your product has formed or not, you have to look at the different characteristic between the reactant and product. Like your product in this case is alkene, so functional group is different. Sometimes the melting point of product is the melting point of the reactant. Based on the chemical reaction, you already know this should be your chemical, this should be your product. So based on the chemical reaction. So if you already have a name for the product, you have physical property for that product. Where do you find it? You could search online. You could search the CRC lab manual, which I showed you beginning of the semester, is a very thick, and I have one copy here, old copy. It's the chemistry and physics handbook. So if you have a structure for a molecule, you have a physical property for that molecule, you find it here. What should be the melting point, for example, or the boiling point, and then you measure the melting point and the / boiling point. Depends if you have a liquid or solid in the lab after you prepare the product, and compare to literature value. If the melting point of the product matches the melting point that is in the literature, then your product is confirmed to be pure, to confirm that the product has formed. If there is a functional group, like in this case, which I'm repeating, but I just want to make sure that when you are studying experiment, when you are doing experiment, you have to pay attention to what's the purpose of this experiment? Why are we doing this experiment? Didn't we know on paper that this is going to happen? But yes, you know on paper that dehydration alcohol will give you alkene, but in the lab, we have to prove that alkene actually has formed. So we have chemical reaction. We have a procedure for the experiment to perform the experiment. That involves a setup of the equipment. So we have to learn about the setup for the equipment. We have to learn about the safety. We have to learn about the lab technique. So when we are setting up distillation, fractional distillation or simple distillation, we have to make sure you know the system has to be sealed, it has to be greased, all those primary factors that you don't want to lose the product, you don't want to get glass joints to be freeze up. And you learned about the technique before, how to assemble it. Now we are using the application to those techniques. Why are we using distillation in this case to separate the product? Can anyone answer that question to me? We are distill the product, right? Basically what is happening here, you have your reactant, you have your reagent, you have your product. When you have the product, you are distilling that product. Basically, you are separating from the reactant using distillation. Does it make sense to use distillation? Can we use recrystallization? Can we use extraction? Can we use something else in this reaction? Why the distillation is a perfect choice or a good choice? That is one of the best choices here. Distillation. Under what condition use distillation to purify a product? You have used few extractions, so few distillations. So I'm sure you have an idea. You just have to tell me. When sample has different boiling point. So what you expect here, the boiling point of the sample, the product is different from boiling point of the reactant. Is it different? You see it's on the screen. You could see the reactant and product. Do you expect different boiling point? What makes the reactant to have different boiling point than product? Can you tell me if the reactant is expected to have different boiling point from product, or we're just assuming that is going to be different? What determines the boiling point? Or what affects the boiling point? What affects the boiling point is the intermolecular forces. What type of intermolecular force you have for the reactant? You have an OH in the molecule that gives a hydrogen bonding for the reactant. For the product, you don't have the OH group, so there is no hydrogen bonding. And what you have on the product side is like you have alkene, which gives you slightly dipole-dipole, but is not very strong dipole. So it's going to be mainly like van der Waals forces and some dipole-dipole. For the reactant, you have van der Waals forces plus hydrogen bonding, which is a very strong intermolecular forces. So you have very strong intermolecular forces. As a result, you are going to get much higher boiling point for the reactant, lower boiling point or different boiling, much lower boiling point for the product compared to the reactant. So when you do distillation, the reactant or reagent is going to stay in the boiling flask, and the product, it would be distilled into the receiving flask. Any questions about the theory for the experiment? No questions? No? Okay. To bring the lab manual, and I take you to the bench for the actual experiment. So you need to know the theory because the questions on the test are coming from also from the theory at the same time that you are responsible for techniques and assembly. You have 2 more experiments and then you have your exam. You could take your exam scheduled. When is scheduled? Next Monday? Your exam is scheduled for Monday? Next Monday? Yes? Okay. You can take it today or you could take it before. You could take it on Friday maybe. We have plenty of time. I mean, there is no rush for me. You don't have to take the exam earlier, but if you have exam for lecture on Monday, for example, then you might take advantage of that, taking your exam earlier to give you time to concentrate for your lecture. You could take it Friday, Saturday, or Sunday if you want. Okay. We already talked about the reaction. Now we have to assemble the fractional distillation. Why fractional distillation? What, can we use simple distillation to make it easier for me for setup? I don't know. We always have this vacuum distillation out here. Can we use simple distillation? Did you answer that, or what factors is going to tell me to use the simple distillation? Yes, in order to know if you are using, you can use the simple distillation or not, you need to know the boiling point. They are not far, okay, enough. If they are not far enough, then you cannot use the simple distillation. So we are using 50 milliliter lamp bottom flask. Okay. I'm going to get the heating handle. set it up. Hardware first. So we're using utility clamp to hold the flask, a 3-finger clamp for the fractionating column. We need the outer ring to support the feeding mantle. What else? What's the next piece of equipment that I need for the assembly? What else do I need? No response? What else do I need? Round bottom flask for the receiving. Okay, very good. So I have to get everything ready before I add my chemicals because I don't want to get the chemicals in here and leave it open. And if I do that, it's going to reaction can take place. And when the reaction can take place, the product is going to escape. So I have to make sure that I have everything ready, set up properly before I can start putting the chemicals in. I know I've done simple distillation and fractionals. So I'm using the fractionating column here with the steel wool in. What's next piece? I have to grease the glass trays. And I'm working with glasses, even without the chemicals. I have to have my safety glasses on. even before I get any chemicals out. Distillation hit. Okay. Next piece. Let's see what's missing. And take a screenshot also and tell me what is missing. Please tell me what is missing. The vacuum adapter is going to connect condenser to the receiving flask. Thermometer adapter, very good. Thermometer adapter, what else? I need the thermometer adapter. I have to grease the thermometer adapter and twist and push. Is anything else missing? I have to place my product in ice to make sure that I get the vapor definitely change to the liquid. Yes, ice that. And bring it up. Okay. Anything missing from the setup? Can you see if anything is missing from the setup? Nothing is missing? No? What about water hose? To attach to the faucet. Because I had for drain, but I don't have one for water going in. Have to make sure the water is running. And going to run it like very slowly. Hopefully this hose is going to hold up because it's not the best one. Let me see if I can change this. Okay. Have the flow of the water. I'm going to make sure that it's even higher because you want to make sure the gas changes to liquid. The product is gas. Okay, the setup is complete. Going to connect the heating metal to the power regulator and wait for this one to be connected. Now, take the flask out in order to add my chemicals. I have everything ready. So when I bring my chemicals, it's to be quickly closed. Everything needs to be closed. We need 10 milliliters of methylcyclohexanol, 50 milligrams of Flask, and 3 milliliters of phosphoric acid and boiling chips. I already add the boiling chips, so I need 10 milliliters of the alcohol plus 3 milliliters of the phosphoric acid. I'm going to add the chemicals and bring it right back. Okay. Now I can plug in the heating metal and Power regulator. Turn it on. What should be the setting? Okay. Questions? Any questions? So we are waiting for the distillation to take place. I can increase it to like between around 70, and as soon as I see it's boiling, I would lower the temperature. I need to get about 8 milliliters, 8 to 9 milliliters of the product. What are the next steps so I could get ready for the chemicals and next step? Okay, when I'm sharing the screen, can you see the setup in the large window, or should I take it out so you could see the video of the setup in the large main window? You can switch. Okay, so you can switch it yourself. I don't have to take the. Don't have to have that. Okay, we can wash the flask. What else do we need to do? Just looking for the next step, so I get ready for with the equipment and chemicals I need for the next steps, the following steps. Based on the procedure. The distillate to separator funnel. So that means I have to get extraction equipment ready. Okay. Get the extractions ready. And how much of water do I have to add? 10 to 15 milliliters of water. Because it's not exact, I can use a flask to do it. Otherwise, it would have to be a graduate cylinder for sure. Just measure the water. Okay. Going to grease the stopper and have it ready until I transfer. Use weighing paper so I don't get grease everywhere. What else do we need while we're waiting? It's getting hot, but definitely not hot enough yet. It's not boiling. It's just starting boiling, so. But it is working. And because it's fractional, it's going to take longer. pH paper to test for water to make sure that is, we want to make sure it's neutral, acidic, or basic. Okay. So we might have leftover of the acid in the reaction. If it's acidic, we have to wash, we have to neutralize it, so we would add the sodium hydroxide. If it's not acidic, then we don't have to be worried about sodium hydroxide, we just wash with water. So the purpose of adding sodium hydroxide for this experiment in extraction steps is to remove any leftover of acid. And what's the purpose of calcium chloride? Adding calcium chloride. Dry out the product. Okay? And after that, we are going to measure the mass of the product and determine the percent yield. Since the gas chromatography is not working, we are not doing the part 14 today. Okay, I need to get some calcium chloride. Is not here. And our lab tech is not. So I'm going to have to go back to prep room. Make sure that we're not receiving yet, but definitely boiling has started. Okay. We may not have to use the aluminum foil, but since I never used it before and this is the last distillation for the experiment for the lab, use of aluminum foil sometimes in this area of the or the fractionating column, it ensures that if the vapor makes it up here, it's going to transfer to the condenser and it doesn't come back. So it's basically making the distillation faster. Because when you see it boiling and it's not making it to the condenser, if something is wrong, you want to make sure that it's actually vapor actually making its way into the condenser. So the use of aluminum foil for the distillation head, it's to contain the heat. I added aluminum foil to this. Let me look for the calcium chloride. I'll be right. Okay. The drops are all the way here, but has not dripped down. It's coming slowly. Okay, good. We have to make sure to stop the distillation before it dries out. Also, you should never still to dryness. That can break the glass. It can freeze the glass. It can overheat the sample, the glassware. Any questions? Okay. Did you take a screenshot of the setup after aluminum? If not, you need to take it now. going to also call for attendance. When the lab starts at 10 o'clock, please be ready to start at 10 o'clock. Okay, do you think we have 8 milliliters? Or not yet? Think we have about 8 milliliters in the flask? How do I know how 8 milliliters or not? How should I know? Any solutions? We need 8 milliliters here. Do we have 8 milliliters or not? Can you help me estimate for 8 milliliters? Are you still logged in? No response? You don't hear me? Is there any problem with the connection? You can't hear me? The mic is not working. Is the mic working? It's working. So do I 8 milliliters here or not? How can I find out I have 8 milliliters? Can I estimate 8 milliliters, 8 to 10 milliliters here? When should I stop? It's foggy. Okay. I tell you, it's right here. Is it 8 milliliters? How do we know? Is 8 or is not 8? It's approximate anyway, but how do we know it is or is not? How can we measure? Should I pour it into graduate cylinder? Okay, that's one way, but if I take it out, I might lose some of the product. If it gets foggy, it's good. Okay, that's foggy. That means it's talking about the boiling flask if it gets foggy, which is not foggy yet. Okay, the boiling flask is not foggy, so it's not stop. But here, if we have anywhere between 8 to 10, we can stop. I explained this procedure before, estimating the volume in a boiling flask. So you take same size flask, another same size flask, take 8 to 10 milliliters of the liquid in, hold it next to it, then you can estimate. So when we were talking about the steam distillation, that I showed you. To get the approximate value, you take a same size flask, you put the liquid water in, safest liquid, water, and then you can estimate. That's about 8 milliliters, but it's not foggy yet. We can continue to get like 10, but I think it's good enough. Going to stop the heat first, lower the heating mantle. Going to lower the heating mantle to stop the heat. And as soon as I don't need the heat, I unplug the electronics. So in case if there is water splash, there is no damage. Wait for the dripping to stop. You can open it for this to slightly cool off. So I don't get, when I open it, I don't get the vapor of the chemical or the product in my face. Okay, no more dripping. I can lower remove the ice. I don't need it anymore. And transfer into the secondary funnel. some water to make sure everything is transferred. I have to mix it because I want to make sure that I'm washing the solution. There's no gas unless I shake it too hard, then the cyclohexene is going to vaporize and creates gas, but there is no reaction that generates gas. It doesn't have too much of the pressure. Okay. I wait for the two layers to form and separate the layers. To test for acidity. Okay. The lower layer is not acidic, and because it's not acidic, I don't have to add the sodium hydroxide, right? The lower level is not, the aqueous layer is not acidic. So I don't have to add the sodium hydroxide. Going to separate. Take a screenshot of the extraction setup. Okay. Is it just the one that you're doing, one chemical test, or two? Are you using bromine also or no? Just the Bayer's test? Okay, just the Bayer's test. We could do both, but it's just one. Is okay. To remove, place in a flask, small dry Erlenmeyer flask. Add the dry of calcium chloride, enough until it doesn't clump. Since they're moving around, that means that it's enough. I'm going to cover it. What's my next step? What's the next step? Okay. While we are waiting for the water to be absorbed, I can do the Bayer's test. So if I add a couple drops of the product into a test tube and add permanganate. Permanganate is a purple color solution. If I add to this compound, the permanganate is going to oxidize carbon-carbon double bond, but it is not going to oxidize alkane. So if it oxidizes, that means you have a CC double bond. How do you know that is oxidized? If the color of the permanganate changes from purple color to brown color. So when you see brown precipitate appears or brown color it's showing and the purple color disappears, that means you have a CC double bond. Okay, so I'm going to show you. Don't know how clear it is. If you need a white background or black background to see the brown precipitate that has formed, do you see it on the wall? The brown precipitate that is forming? So if I use some acetone, it's going to wash this down and might be easier for you to see. Now, the purple color, it shows that you have permanganate. If the purple color disappears, or when you see brown precipitate forms, that means your compound is carbon-carbon double bond. So we are going to wait for the purple color to disappear. I don't know if you could see the brown precipitate forming here. And if you see it, let me know. Bottom of the test tube, do you see the brown precipitate? Yes? Okay. That brown precipitate means that you have CC double bond. So that's a positive test for the Bayer's test or positive test for CC double bond. If I wait long enough, the purple color would disappear. I'm not discarding this, but I'm just going to continue with the other part of the experiment and come back to this and I show you again. You could take then you could take the screenshot of it. So I'm just going to keep it here, wait, and what I'm going to do with the other product, I need to measure the mass of the product. So in order to measure the mass, how should I measure the mass of the product? Can I measure the mass of this flask? To measure the mass of product, can I measure the mass of this flask? Okay. In a beaker, what part should go into the beaker? Just the liquid part, right? We want to separate the cat. The point is to recognize that calcium chloride is not your product. Calcium chloride is just something to absorb the moisture from your product. So in order to measure the mass, you first separate that. And then when you separate, you measure the mass of the liquid portion only. You can use either a beaker or a flask, But for transferring purpose, beaker is easier. I don't want any splashes. So I'm going to, okay, because this is just one step. I already have my compound. I don't have to dry it. I don't have to take it back and bring it back. I can just tear this. This way I get one number for the mass of the product. Then I transfer the liquid portion without any solid getting in there. No solid should go into the beaker. Okay. To the last drop. And now you take a screenshot of the mass of the product. You have a screenshot? Perfect. Okay, and we are done with this experiment part. I just want to make sure that the purple color disappears. I'm going to add a couple more drops of this so you could get a better test result to make sure that actually it's very obvious the color change. You already see that the purple color is much lighter, is not purple anymore. Okay. See the brown color? You can take a screenshot of this also. It can be included in your lab report as the evidence for the reaction. So the values that you need in the abstract and you need for the conclusion would be the purple color. Yes, whatever the screenshot shows is fine. You can record that. It could be just 147 or 148 or any number that you got is fine. So it's the disappearance of the purple color or appearance of the brown color and the mass, which is the mass percent yield, but we do not have the percent composition. Mass and percent yield. Okay, any questions? No questions? Okay. Going to stop recording and check for attendance to make sure everyone is active.